Welcome. We're going to make polynomials when we're given the zeros, and some of these are going to have the imaginary number. So let's start with this first problem. We're going to write a polynomial factor of least degree, meaning the smallest amount of degree possible, and we have these zeros, 9 and -3. Integral coefficients means not decimals, fractions, but rather with positive, negative numbers, whole numbers and their opposites. So first, if these are zeros, that means that they were at x equals 9 and x equals -3. We got x equals 9 because it was originally x minus 9 equals 0 and x plus 3 equals 0. And then we added 9 to both sides and subtracted 3 from each side. These are the roots. So these are the zeros, and then these are the roots. And what we do to make a function is we take the roots back to where they were and multiply them. So I'm going to multiply the x times both of those and the -9 both of those. I get that the function of x is equal to 9x minus 27. And then I need to combine the like terms. So we get x squared minus 6x minus 27. And that would have been the original function that we factored in order to get those roots of x minus 9, x plus 3, then apply the zero product property in order to move them to the other side with each with their own zero to tell us what the zeros were. And if we put 9 in here for x and in the x squared and in the -6x and worked it out, it would be 0. And if we put -3 there, it would also be 0. Now let's do it when it's a little more complicated because there's 3 of them. Well, it actually doesn't change anything. We're going to have this one opposite sign, this one opposite sign, so that it's a -4 and a +7 inside the parentheses with the x. And then the -2 becomes a +2. So our function is equal to all 3 of those. And what we do is the same thing as the last problem. We just simply multiply them. Now, you just multiply 2 of them at a time. I'm going to start at the back, and I'm going to do the x is x plus 7 times the x plus 2. It doesn't actually matter which order you do the binomials, as long as you do 2 of them at first, and then multiply the other one to it. So that's going to be plus 2x and plus 7x is plus 9x. And then 7 times 2 is the 14. And now I'll apply the, now there's a bunch of these. So in this case, I'm going to do it a little differently. X times x squared is x cubed. And then x times 9x is minus 9x squared. And x times 14 is plus 14x. Then I'm going to do the -4 times the x squared, but I'm going to put it underneath the other x squared. And -4 plus 9x, well, 9 times 4 is 36, so that's a -36 x here. Do I have that right? Okay, I believe so. 14x -4 times 9 is -36x. That looks about right. And then -4 times 14 is a negative, and that's a -56. So now I will put those together. I could have had them in just one long line to have worked this out also, but instead I'm going to work it this way. Uh-oh. Oh, okay, this looks good so far. I'm just looking at my negatives and following a negative plus and a plus. And I'm wanting to be careful with the negatives, but I believe that I'm in good shape on these. X times those. Ooh, I see a problem here. It's a good thing I stopped to look at it, because when I looked at this x times this 9, it should have been a plus 9x. So I knew something seemed to be off to me. I'm glad it stuck in my head and I went back and checked. and then the 14, that looks right, and then the negative 4 times the x squared, negative 4 times the 9, and negative 4 times 14. All right, all looks good right now. So that means this is an x cubed. 9 take away 4 means it's a plus 5x squared. And here we have a 14 minus a 36. So I'm going to do 13 take away 14. And then I will do the, and then I will change the sign. So 36 take away 10 would have been 26, and another 4 is a 22. So this should be a negative 22x. Well, here then, if I do negative 22 and take away 14, I'd get 36. I believe that's right. So negative 36 take away 14 is negative 22. If I use a calculator, I'd be certain of getting that, but I can do that one now carefully and know that's correct. So the next thing is to make sure our exponents are in order. An exponent is 3, then a 2, then a 1, and then none, or next to the 0. And that means that this is the polynomial. There it is. This is the polynomial that results from these 3 zeros. If we now took this and factored it and broke it down, we would get x minus 4, x plus 7, and x plus 2. Now, okay, now let's go here to this next one. Write a polynomial function with an imaginary 0. Now we're going to start using the letter I. Okay, and here's the first main thing to recognize. They come in pairs. So if they come in pairs, that means now the next step is to include the second one. So negative I also has positive I with it. So what we really have, this is automatic. Automatic. Don't forget it. They're called the conjugates. This is called the conjugate. In fact, I'll put that word here, because you'll see that a few more other times. So this is a really important key thing. So what that means is that we have 3 negative I and we have positive I. So you have to make sure you include that. So that means the function of x is going to be equal to x minus 3. So use the opposite sign with each of them. X plus I and x minus I. Now, many people would start at the beginning and do x minus 3 times x plus 1, and you can do that. But you just change this from about a 6-step problem or 7-step problem into a 20-step problem. Don't do that. Instead, multiply the I binomials first. And the reason for that is because some things will cancel out. So watch what happens when I multiply this here. I'm going to keep the x minus 3. X times x means x squared minus xi plus xi, and then minus I squared. Right here, these will cancel out. And the next thing is that remember that I squared is equal to negative 1. That's because the square root I squared is I is negative 1. And if you square it, you get square root of negative 1 times square root of negative 1. So, or it's like the square root of negative 1 squared, and those cancel, so you get a negative 1. So back here. Because of that, we have x minus 3 and x squared now minus the I squared is a negative 1. So we have f of x minus 3, x squared plus 1. And now all we need to do is to multiply those. X times x is x cubed plus x minus 3x squared minus 3. We have to put that in the correct order. So the x cubed is first, the negative 3x squared is next because of the next highest exponent, then the x, then the minus 3. And there is our polynomial resulting from using 3 and I, which meant 3I and negative I. Okay, let's do it again with this number this time. So I know if I have 7I, I now have negative 7I. So that means that the function is equal to x plus 5 using the opposite sign, x minus 7I using the opposite sign, and x plus 7I using the opposite sign. But here, x times x is x squared. Well, actually, let's start writing it. So x times x is x squared, but positive 7I and negative 7I are going to cancel out. So I'm not even going to write those. But I am going to do the negative 7 plus 7, that's negative 49I squared. But I squared equals negative 1. So that means we'll have negative 1 times negative 49 to make a positive. Well, let me write that out. That's x squared plus 49 now, because negative 49 times negative 1 is a positive 49. All right, now I'm going to multiply the x times these and the 5 times these. So I get that the function of x is equal to x cubed plus 49x plus 5x squared plus 5 times 40 is 200, and 9 is 45. This would have to be 245. And then we have to put it into the correct order. So there, plus 5x squared plus 49x plus 245. And that is the result of using zeros of negative 5 and 7i, because the 7i also has a negative 7i with it.